Section 4.1, we want to look at rules for exponents. We have a product rule that says when we multiply exponentials, we add the exponents. We have a quotient rule, which tells us when I divide exponentials, I subtract the denominator exponent from the numerator exponent. And of course, I can't divide by 0, so this base a can't be 0. The zero power rule says a to the 0 is 1, as long as a isn't 0. The negative power rule says a to the negative n is 1 over a to the nth, or 1 over a to the negative n equals a to the n, as long as a isn't 0, because I can't divide by 0 ever. The power to power rule says a to the m to the nth is a to the m times n. Product to power rule says a times b to the nth is a to the nth times b to the nth. The quotient to power rule says a over b to the nth is a to the nth over b to the nth, as long as b isn't 0. So these rules are going to be used to simplify exponential expressions. An exponential expression is simplified when no parentheses or grouping symbols are present. Also, no zero or negative exponents are present. And no powers are raised to powers. Each base occurs only once. So we want to get number 1 in this form. So one of the things we see that I'm going to address right away is that we have negative exponents. So when I cross the fraction bar with an exponential expression, the exponent changes sign. So when I bring the denominator expression to the numerator, the negative 25 becomes a positive 25. The power of negative 2 in the numerator becomes a power of positive 2 in the denominator. So when you cross the fraction bar, exponents change signs. So now I'm using the product to power rule. X times y to the 25th is x to the 25th y to the 25th. 3x squared y cubed to the second is 3 to the second x squared to the second y cubed to the second power. So my numerator is x to the 25th y to the 25th. And now let's simplify our denominator. 3 squared is 9. X squared squared is x to the 2 times 2. Y cubed squared is y to the 3 times 2. So I'm using the power to power rule here. Let's recopy this numerator and let's simplify our denominator, which is 9x to the 4th, y to the 6th. And now let's use our quotient rule. X to the 25th divided by x to the 4th is x to the 25 minus 4. Y to the 25th divided by y to the 6th is y to the 25th minus 6. So I now have x to the 21 times y to the 19th over 9. So I fulfilled all of the requirements for a simplified exponential expression. No grouping symbols are present. There are no negative or zero exponents. No powers are raised to powers. Each base occurs only once. So this answer is in its simplest form. Let's apply this to number 2. So first I'm going to deal with the negative exponents inside of each parenthesis. So the power of negative 3 in the numerator becomes a power of positive 3 when I move that exponential expression to the denominator. On the second expression, the power of negative 2 in the denominator on C becomes a power of positive 2 when I move it to the numerator. The power of negative 1 on A in the numerator becomes a power of positive 1 when I move that expression to the denominator. So I'm going to recopy the first parenthesized expression, and now I'm going to deal with this outer exponent on the second expression by inverting the fraction. So when a negative exponent is applied to a fraction, invert the fraction and change the sign of the exponent. And one thing you want to be careful of on these problems is not to try to do too much at once. That's how most people make mistakes. So now I'm using the quotient to quotient rule, quotient to power rule, and also the product to power rule. So I'm squaring everything in each numerator and every expression in each denominator. Okay, so now when I square a negative 2, I get a positive 4. Negative 2 times negative 2 is positive 4. When I square a to the 4th, I get a to the 8th, and that gets multiplied in the numerator by a squared. 9 squared is 81. I'll move that number factor in the front. B cubed squared is b to the 6th. C to the 4th squared is c to the 8th. B to the 8th squared is b to the 16th. C squared squared is c to the 4th. So in those 4 instances, I was using the power to power rule. So now I'm using the product rule. A to the 8th times a squared is a to the 10th. B to the 6th times b to the 16th is b to the 22nd. C to the 8th times c to the 4th is c to the 12th. I can't simplify 4 over 81 at all. That's my final answer. Now I want to convert from standard form to scientific notation. In scientific notation, a number is written with 2 parts. The first part of the number is a number between 1 and 10, not including 10. The second part of the number is a power of 10 that's multiplied by the first part. So when I take the number 3 and I write it in scientific notation, I move the decimal, which is at the end of the number, so that there is only one digit to the left of the decimal, and that is a 3. I recopy the other numbers. I don't need to write ending zeros that are to the right of a decimal. And then I have moved the decimal 14 places to the left. So I compensate for that by writing a positive 14 as my power of 10. On number 4, the decimal is moved between the 7 and the 8. And I've actually moved the decimal 7 places to the right. So I compensate for that by making a power of negative 7 on my 10. Now I want to write numbers in scientific notation in standard form. So in the first case, I copied down the 5 digits of the number, and this number is multiplied by by 10 to the negative 9th. So I'm going to need to move the decimal in the 5.3789 9 places to the left. So I need to move that number over so I have room to do that. So there's 1 place, and I'm going to move the other 8 places by adding 8 zeros. And then writing the decimal point. And then I always put, for good form, a leading 0 to the left of the decimal point. Now in number 6, I write the 225 and I've moved the decimal 2 places. I need to add 4 more zeros to move it a total of 6 places. So sometimes I want to multiply and divide numbers that are in scientific notation, and I always want to put the final answer in scientific notation. Here are 2 examples, one where I'm multiplying, the other where I'm dividing. So I multiply, in the first example, 1.8 times 3 to give 5.4, and I multiply the powers of 10 and simplify. And notice that turns out automatically to be in scientific notation. So there's nothing else for me to do. In the second case, I divide the 2.16 by the 4.5, and I multiply that by the division of the power of 10. So I regroup the factors. And then when I divide 2.16 by 4.5, I get 0.48. And notice that is not in the scientific notation form, so I change it to the form of scientific notation. So let's look at applying that to number 7. 5.3 gets multiplied by 9.4. And then I multiply that by the product of the powers of 10. So 10 to the negative 9th gets multiplied by 10 to the 39th. So when I multiply 5.3 times 9.4, I get 49.82. And when I multiply 10 to the negative 9th times 10 to the 39th, I add the exponents. That's the product rule. Now, 49.82 is not a number between 1 and 10. So I move the decimal so that there's only one digit to the left of the decimal. But I have to account for that movement to the left by putting a power of 1 on 10 and multiplying that by the 4.982. And so 10 to the negative 9th times 10 to the 39th is 10 to the 30th. But now I have to multiply that by that 10 to the 1st that came from converting my 49.82 to scientific notation. So I need to multiply these 2 powers of 10. And I wind up with 4.982 times 10 to the 31st as my final answer. Here I want to do a division. 1.3 will be divided by the 9.58. So I'm regrouping my factors. And now I do the division between the powers of 10. 10 to the 18th is divided by 10 to the negative 52. So when I divide 1.3 by 9.58, I actually get a number 0. These are the digits that showed up on my calculator. 0.135699373 times 10 to the 18 minus negative 52. So remember, I subtract, in the quotient rule for exponents, I subtract the exponent in the denominator from the exponent in the numerator as long as the bases are the same. And so you want to make sure you subtract negative 52 and not just a 52. So this actually turns into an addition of 18 and 52. All right, now notice my 0.135699373 is not in a number between 1 and 10. So I need to move the decimal. I'm going to go ahead and simplify 10 to the 18 plus 52 to 10 to the 70th. And then I'm going to write this number in the red parenthesis in standard form. It's for my scientific notation form. So I move the decimal one place to the right. I make up for that by putting a power of -1 on 10. So I recopy my 1.35699,373. I multiply 10 to the -1 times 10 to the 70th to get 10 to the 69th. So my final answer is 1.35699,373 times 10 to the 69th.